All right, so picture this. You're walking into that electronics engineer interview,
Oh, I know the feeling.
but not with like sweaty palms,
Mm-hmm.
but with calm confidence, ready for anything they throw at you.
That's the goal, right?
Yeah, that's what we're going for today. We're diving deep into electronics engineer interviews.
Deep dive.
And I've got some awesome resources from RoleCatcher
Love RoleCatcher.
to help us navigate this whole thing. Think of them as your secret weapon for acing that interview
Secret weapon. Love it.
and landing your dream job.
That's the dream.
All right, so first things first, let's get a real grasp on what electronics engineers actually do in the real world.
Okay, sure.
RoleCatcher's career guide goes way beyond, the textbook definitions.
Yeah.
And it's fascinating how electronics engineers are involved in almost every single part of our lives.
It really is.
I mean, think about it. Smartphones, medical equipment,
Oh, I know.
even the traffic lights we see every day.
It's everywhere.
These systems wouldn't exist without the work of these skilled electronics engineers.
Right, exactly.
And with emerging technologies like nanotechnology
Wow. Yeah.
and this increasing demand for wireless and mobile devices,
Constantly changing, right?
the field is constantly evolving.
Absolutely.
So how do you show an interviewer you can keep up with that crazy pace of change?
Good question.
That brings us to our first interview question.
Hit me.
How do you stay up to date with the latest advancements in electronics?
Okay, so this is your golden opportunity, right?
Yeah.
To show you're not just technically competent, but also super passionate about the field
Yeah.
and committed to, constantly learning new things.
Always learning.
So instead of just like listing generic websites,
Yeah.
mention specific publications,
Okay, like what?
like IE Spectrum
Yeah.
or electronics letters.
I've actually been meaning to check out some of those myself.
They're great.
Are there any particular, sections or topics
Oh, yeah.
you find especially insightful?
For sure. So I've been really interested in articles about the development of RISC-V processors
Interesting.
and their potential impact on embedded systems. It's really cutting edge.
Wow.
Could really revolutionize the way we design electronics.
See, that's the kind of detail
Yeah.
that makes an answer stand out.
Absolutely.
Shows you're really engaged.
Yeah.
Not just saying what you think they want to hear.
Exactly. You can also talk about online communities, forums where you actively participate,
Oh, yeah.
in discussions about new tech.
Rare.
Shows you're part of the conversation,
Yeah.
contributing to the knowledge of the field.
Love it. And that brings us to another important element of staying current
Right.
conferences. RoleCatcher's guide really hits on how important those are.
They are.
So why are conferences so important?
So conferences, right? They're fantastic opportunities to network with other professionals, learn about new trends, even get hands-on experience with new technologies.
Right.
And then you can mention specific presentations or workshops
Okay.
that you found helpful to your work.
That makes a lot of sense.
Okay.
Okay, let's say you're in the interview.
Right.
You aced the staying up-to-date question.
Yeah.
And then they hit you with this.
Okay.
What inspired you to become an electronics engineer?
Oh, good one.
How do you tackle that one?
So this one, right?
Right.
It might seem like a simple warm-up,
Yeah, for sure.
but it's actually a chance to stand out
Okay.
and make a real impression.
Right.
Think back to what really sparked your passion.
Mm-hmm.
Was it a childhood fascination with taking things apart?
I feel like a lot of engineers I've talked to.
I know, right?
They started with Legos
Totally.
or just building things with whatever they could find.
Yeah, exactly. That's a great example.
Yeah.
Sharing something personal like that can make your answer way more relatable,
Mm-hmm.
way more engaging. You're not just reciting a rehearsed answer.
Yeah.
You're sharing a part of yourself.
Right.
And you can even take it a step further, right?
Yeah.
Connect your personal story to your career goals.
Oh, I like that.
How that initial spark has shaped your aspirations.
It's like weaving a narrative
Yeah,
that shows your passion and makes you stand out.
exactly. All right, let's get into a more technical one now.
Okay, hit me.
One that comes up a lot.
Mm-hmm.
Can you describe your experience with PCB design?
PCB design, right?
This one's all about your practical skills and experience.
Okay.
So start by mentioning the specific PCB design software you're good at,
Like what kind?
like Altium Designer
Great.
or Cadence OrCAD.
Got it.
Walk them through your design process,
Yeah.
highlighting key steps like schematic capture, component placement.
So it's not just listing the software.
Yeah.
It's about showing you really understand the design process.
Absolutely. And to impress them even more, you can dive into a specific project
Okay.
that involved PCD design.
Okay.
Talk about the challenges you faced, the solutions you came up with,
Right.
and the lessons you learned.
I like it.
For instance, you could mention a project where you had to design a PCB with very limited space.
Okay, that's a tough one.
Right.
How'd you do it?
And then explain how you used innovative techniques,
Like what?
like blind and buried vias to keep the board small while still meeting all the requirements.
That's impressive.
Thanks.
So you've shown your technical expertise,
Yeah.
problem-solving skills,
Mm-hmm.
even thinking outside the box.
Right.
But how do you make sure your answers are tailored to the specific job you're applying for?
That's where RoleCatcher's AI comes in.
The AI.
Yeah. Their Copilot feature analyzes job descriptions,
Okay.
identifies the most relevant skills,
Yeah.
and then it helps you craft, like, tailored responses
Wow, that's cool.
that really highlight your strengths.
So let's say the job description emphasizes experience with microcontrollers.
Okay.
RoleCatcher would pick up on that
Yeah.
and suggest like specific examples
Right.
related to microcontrollers in your answers.
Exactly. It's like having a personal interview coach, right?
Right.
Who knows what the employer is looking for?
Yeah.
It can even give you feedback on your delivery.
Oh, wow.
Suggest ways to improve your tone, pacing, all that.
That's awesome.
Yeah.
Okay, speaking of microcontrollers,
Yeah.
let's tackle another common question.
All right.
Can you describe your experience with microcontrollers?
So here's where you really show off your knowledge of embedded systems
Okay.
and your ability to work with both hardware and software.
Yeah.
Start by mentioning the specific microcontrollers you're familiar with,
Like, for example?
like those from ARM or Microchip.
Okay.
Discuss your experience with programming, debugging,
Right.
and interfacing with other components
Okay.
using communication protocols
Okay.
like SPI and I2C.
Now, I know SPI and I2C are common,
Yeah.
but for those who may not be familiar,
Yeah, sure.
could you give us a quick explanation?
Of course. So SPI, or Serial Peripheral Interface,
Okay.
it's a synchronous protocol
Got it.
that uses separate lines for data transmission
Okay.
and clock synchronization. It's often used for high-speed communication between a microcontroller and peripherals.
Oh, like sensors.
Exactly, like sensors or memory chips.
Got it.
And then I2C, or integrated circuit.
Okay.
It's a two-wire protocol
Okay.
that uses a shared bus for data and clock signals.
Got it.
It's known for being simple and having a low pin count.
Right.
So it's good for applications where space is limited.
That's super helpful.
Yeah.
It's always good to have those explanations ready, you know?
Absolutely, just in case they want you to elaborate.
Exactly.
And don't forget, the best way to show off your microcontroller skills is through real-world examples.
Oh, yeah, for sure.
Describe a project, where
Right.
you used a microcontroller-based solution,
Right.
highlighting the challenges and the results.
So instead of just saying, I'm familiar with ARM microcontrollers, you could say, in a recent project, I used an ARM Cortex M4 microcontroller to develop a real-time control system for a robotic arm.
Exactly.
I programmed a microcontroller in C++E using an RTOS to manage multiple tasks and ensure deterministic timing.
Perfect.
Wow, that's a powerful answer.
Right.
Shows you have the experience.
Yeah.
You understand those nuances,
Uh-huh.
and you can communicate it all clearly.
Exactly. All right, we've talked about staying up to date, your inspiration for becoming an engineer,
Yeah?
your experience with PCB design,
Yeah.
and microcontrollers.
That's a lot.
Let's move on to another crucial part of electronics design,
Okay, what's that?
troubleshooting.
Troubleshooting.
It's a fundamental skill, right?
Yeah.
It's not just about fixing stuff.
Right.
It's about really identifying the root cause
Yeah.
and coming up with a good solution.
Okay, so how do you show off your troubleshooting skills in an interview?
Yeah.
Especially when you can't actually, like, poke around a circuit board
Right.
and use your multimeter.
So when they ask, how do you approach troubleshooting complex electronic systems?
Yeah.
They want to see a structured approach, a logical approach.
Right.
Walk them through your process,
Okay.
starting with identifying the symptoms, what's not working,
Right.
any error messages or weird behavior,
So it's like gathering information
Yeah.
like a detective in a crime scene.
and then Once you understand the symptoms, right?
Yeah.
You can start isolating potential causes.
Oh,
Is
yeah.
it hardware or
Yeah.
software?
Boy.
Power supply, the components, the connections.
This is where your knowledge of circuits comes in.
Absolutely.
Components
Yeah.
and testing techniques.
You might use a multimeter
Okay.
to check voltages and currents,
Right.
an oscilloscope to visualize signals, or a logic analyzer to debug digital circuits.
Okay.
And don't be afraid to mention specific tools and techniques,
Right.
Shows you're not just talking,
You've got the experience. And of course, they want to see how you apply your skills in real situations.
For sure.
Duh.
Be prepared to describe a specific troubleshooting scenario from your past.
Yeah.
Walk them through the steps, the challenges, the solution you came up with.
It's a chance to show off your problem solving
Yeah.
and your ability to think under pressure.
Exactly. And don't be afraid to talk about a time you messed up.
Oh, yeah.
What matters is that you learned, right?
Right.
And applied those lessons to future projects.
It shows you're self-aware and,
Yeah,
committed to improvement.
absolutely.
Okay, we've covered a lot of ground so far,
We have.
but there's still more to explore.
Oh, yeah, for sure. All right, welcome back to our deep dive into acing those electronics engineer interviews.
We've tackled some pretty tricky technical questions so far.
We have.
But now
Yeah.
let's zoom out a bit
Okay.
and talk about a crucial part of electronics design.
Okay.
Making sure your creations meet safety and regulatory standards.
Yeah, safety first.
You can't just, build a cool gadget and send it out into the world without making sure it's safe, right?
Exactly.
So how do you handle a question like, how do you ensure your electronic designs meet all relevant safety and regulatory standards?
So this is where you really show your professionalism.
Okay.
And that you're committed to, responsible engineering.
Right.
You want to show them that you're not just like a circuit whiz,
Yeah.
but someone who really takes safety and compliance seriously.
Right. Takes it to heart.
So start by mentioning your familiarity with those key industry standards like UL, CE, and FCC.
Okay. I've definitely seen those acronyms before, especially on devices I buy.
Yeah.
But to be honest, I'm not totally sure what they stand for.
Yeah, okay, no problem.
All
So
right.
UL stands for Underwriters Laboratories,
Okay.
which is a global safety certification company that tests products
Yeah.
to make sure they meet those safety standards
Got it.
for fire, electric shock, other hazards.
Okay.
Then there's CE marking. That shows that a product complies with the European Union safety, health, and environmental protection standards.
So that's for Europe.
Yeah, exactly.
Got it.
And then FCC stands for the Federal Communications Commission.
Okay.
They regulate radio frequency emissions
Right.
from electronic devices in the U.S.
So basically, these organizations are making sure that our gadgets don't burst into flames or interfere with each other's signals.
That's a good way to put it.
Yeah.
But it's not enough to just know the acronyms, right?
Okay.
You need to explain how you incorporate safety into every step of your design process.
Yeah. So what kind of things do you do?
Well, for instance, you could mention using safety components
Yeah.
like fuses, circuit breakers, overvoltage protection circuits.
Oh, right. To prevent things from, going haywire.
Exactly.
Got it.
You can also talk about doing thorough testing
Yep.
simulations to make sure your designs meet those standards.
It sounds like documentation is really important here, too.
Oh, it's a crucial. Yeah,
You want to show that you followed those procedures
right.
and kept track of everything.
So you have that paper trail.
Exactly.
Hmm.
Documentation is key for compliance and traceability.
Makes sense. Okay, so you've nailed the safety question.
All right.
Impress them with your attention to detail, and then they hit you with this.
Okay, what is it?
Can you describe your experience with analog circuit design?
Oh, all right, here we go.
This is where it gets real, right?
This is your chance to dive into the fundamentals.
Okay.
Start by laying out your knowledge of those key concepts,
Like what?
like signal conditioning, amplification,
Right.
filtering, feedback.
Got it.
These are the building blocks, right?
Right.
And showing that you understand them is key.
So instead of just saying, yeah, I know analog circuits,
Right.
you'd want to give specific examples
You see-
of circuits you've designed,
Yeah.
the techniques you've used.
You could mention your experience designing amplifiers
Okay.
for audio.
Filters for signal processing, oscillators for clock generation.
So it's about showing your versatility
Yeah.
and depth of knowledge.
Exactly.
Let's say you're talking about amplifiers.
Okay.
Would it be helpful to mention different types?
Oh, absolutely.
Okay.
Like operational amplifiers
Yeah.
or transistor amplifiers.
Yeah.
Mentioning those specific types shows you understand the nuances.
Right.
You could talk about using an operational amplifier to build an active filter
Okay.
for a specific frequency range.
Got it.
Or designing a transistor amplifier for a
Well-
high-power audio application.
So you're giving them concrete examples.
Exactly.
Okay, now let's talk about the digital side of things.
All right.
What if they ask, can you describe your experience with digital signal processing?
DSP.
DSP, yeah. That sounds pretty intense.
It can be,
Yeah.
but it's also really exciting.
Okay.
DSP is becoming so important in so many applications.
Like what kind?
Like audio and video processing, telecommunications, even medical imaging.
Wow, it's everywhere.
So if you have experience with DSP,
Yeah?
this is your time to shine.
Okay, so what kind of things should you be highlighting in your answer?
All right. Start by discussing your knowledge of algorithms.
Okay.
Like FIR and IR filters.
Okay, those names ring a bell from my signal processing classes.
Yeah.
But could you give us a quick refresher?
Of course. So FIR stands for finite impulse response.
Okay.
And IIR stands for infinite impulse response.
Okay.
They're the fundamental digital filter types.
Got it.
Used all over the place.
Okay, so what do they actually do?
So FIR filters,
Yeah.
they have a finite impulse response, meaning their output goes to 0 after a certain number of input samples.
Okay.
They're known for their stability and linear phase response.
Right.
So they're good for applications where you don't want distortion.
Makes sense.
Then you have IIR filters.
Yeah.
They have an infinite impulse response.
Okay.
So their output can theoretically go on forever
Oh, wow.
after an input signal. They're often more computationally efficient than FIR filters for achieving a specific filter characteristic.
So FIR filters are like a quick burst of energy,
Yeah,
and IR filters are more like a sustained ripple.
that's a great way to think about it.
Yeah.
You can also mention your experience with other DSP techniques,
Okay.
like the fast Fourier transform.
The FFT.
Yeah,
Ah, another blast from the past.
it's a powerful algorithm
Yeah.
for transforming a signal from the time domain to the frequency domain.
Okay.
So you can analyze its frequency content.
Right.
It's used in a ton of applications,
Yeah, like what?
like spectrum analysis, image compression.
Cool.
It sounds like having a good grasp of these DSP concepts is really important
It is.
for tackling those more complex problems.
For sure.
And to really show off your expertise, you can mention specific software tools you've used,
Oh, yeah, like what?
like MATLAB or Python libraries.
Okay, now let's shift gears a bit. Talk
Yeah.
about the software side of electronics engineering.
Okay.
If they ask, can you describe your experience with firmware development?
Firmware.
Firmware.
It's the software that runs on embedded systems, right?
Right.
Controlling the hardware,
Yeah.
making it do those specific tasks.
It's like the brains behind all the cool gadgets.
Exactly.
So how do you approach this question?
So walk them through your firmware development process.
Okay.
From writing code to debugging, testing.
Right.
Mention the languages you're comfortable with,
Like what kind?
like C, C++, the assembly language.
Assembly. Wow, that's getting down to the nitty gritty.
Yeah, it's that low-level programming
Right,
close to the hardware.
And since we're talking about embedded systems,
Yeah,
should you mention real-time operating systems?
RTOS.
RTOS. Yeah, I remember that term.
Oh, yeah.
For my
From-
embedded systems classes.
And RTOS is designed for real-time applications, right?
Right.
Where tasks need to be done super fast,
Okay.
like right on time.
Got it.
So mentioning that shows you understand those challenges.
Of embedded systems development.
So even if you're mainly a hardware engineer,
Yeah,
showing some software skills makes you more well-rounded.
absolutely.
Right.
Employers love engineers who can work across those disciplines.
Right. It's all connected.
Yeah.
Okay, we've covered a lot of technical questions.
Yeah.
But let's not forget those soft skills,
Right.
especially in today's collaborative world.
Yeah, teamwork makes the dream work.
What if they ask, can you describe your experience with project management in electronics engineering?
Oh, okay. This is where you show off your leadership skills
Right.
and how well you work on a team.
So it's not just about managing projects. It's
Right.
about leading people
Yeah,
and building that collaborative environment.
exactly.
Okay, so what should you talk about?
Think back to projects where you, took charge.
Yeah.
Even if it wasn't officially a project manager role.
Right.
Talk about how you handled deadlines, communication, teamwork.
Right.
Did you use any specific project management methods?
Like what?
Like Agile or Waterfall?
Okay.
Did you use any project management software?
Like Jira or Trello.
Yeah, those are good examples.
And it's okay to talk about challenges you faced.
Oh, yeah.
And how you overcame them, right?
For sure.
It shows you can learn from mistakes.
Absolutely. Everyone makes mistakes, but what matters is how you handle them.
Right. It's about growth.
Yeah, exactly.
All right, we've covered a ton in this second part.
I know, right?
We've explored safety standards, analog and digital circuit design, firmware development, even project management.
That's a lot.
And throughout all of this, we've been using insights from RoleCatcher's Career Guide.
It's a great resource.
And talking about how their AI tools can help.
Those AI tools are game changers.
But we're not done yet.
Oh, there's more.
In the final part, we'll shift gears away from the interview itself. And look at the bigger career landscape for electronics engineers.
Sounds good.
We'll explore different career paths, specializations.
The value of certifications. And the often overlooked aspect of networking.
Networking is key.
So stay tuned for more insights and strategies to help you land that dream job. All right, welcome back to the final part of our electronics engineer deep dive.
The grand finale.
We've prepped for those tough interview questions. Gotten some great insights from RoleCatcher's Career Guide.
So helpful.
And even explored how AI can give us that extra edge.
AI is changing the game.
But there's one more crucial piece of the puzzle we haven't talked about yet.
What's that?
Networking.
Networking, yes.
It's often seen as something you do after you've got the job.
Right. Yeah.
But it can be just as important during your job search.
Absolutely.
And even for shaping your whole career path.
Couldn't agree more.
And it's not just about, collecting business cards at events.
No, not at all.
It's about building those genuine connections.
Real relationships.
Learning from others.
Yeah.
Creating a support system.
A network of like-minded people.
It's fascinating how networking can open doors to opportunities you didn't even know existed.
So, it happens all the time.
It's like expanding your radar, right?
Exactly.
Talking to people in the field gives you those insights into different companies.
Yeah.
Work cultures, even emerging trends.
It's like getting a sneak peek behind the scenes.
RoleCatcher's Career Guide really emphasizes attending industry conferences and trade shows.
Yeah, they're great for that.
So what makes them so valuable for networking?
Well, think of conferences like concentrated hubs of knowledge and connections. You're surrounded by experts learning about cutting-edge research. And you have those chances to just strike up conversations with people who are passionate about the same things you are.
I can see how that would be energizing.
It really is.
You might even meet your future mentor or collaborator.
It happens all the time.
The guide also mentions connecting with electronics engineers through online platforms like LinkedIn.
LinkedIn is huge.
In today's world, online networking is just as important as those in-person events.
I'd say even more so in some ways.
So how do you make the most of LinkedIn for networking?
So LinkedIn is like your online resume and portfolio.
Right.
You're showcasing your skills to a global network.
Wow.
It's also a great way to stay updated on job openings.
Yeah, the job postings.
Connect with people at companies you're interested in. Even participate in discussions about industry trends.
So it's not just about having a profile.
Right.
It's about actively engaging.
Yeah. Join groups, share your thoughts, build relationships.
Like a virtual conference that never ends.
Exactly.
Now, speaking of showcasing your skills.
Yeah.
The Career Guide also suggests creating a portfolio.
Oh, yeah. A portfolio is a great idea.
Of your projects and designs.
Especially if you don't have a ton of work experience.
Right, because sometimes a project you built in your garage can be just as impressive as something you did at a company.
Absolutely.
It shows initiative, a love for learning.
It shows passion.
Even outside of work.
Don't be afraid to think beyond the traditional resume.
Yeah.
Create a website or online portfolio.
Oh, okay.
That showcases your work in a visually appealing way.
Right. Make it look good.
Include photos, videos, even code snippets.
Oh, wow.
To give potential employers a better idea of your skills.
It's like telling the story of your engineering journey.
I like that.
Through those projects.
Yeah.
That highlight your passion in problem solving.
Exactly.
Now, how do you keep track of all these connections and interactions?
That's a good question.
It can get overwhelming, right?
It definitely can.
Especially if you're networking both online and offline.
Yeah, that's where RoleCatcher comes in handy again.
Oh, RoleCatcher to the rescue.
Their network management tool lets you import and organize all your contacts. Link them to job applications.
Oh, that's cool.
Even track your interactions.
So it's like a CRM for your professional relationship.
Exactly.
I love it.
It streamlines your approach.
Yeah.
Makes it more strategic.
No more messy spreadsheets.
Right.
Or forgotten follow-ups.
You can categorize your contacts.
Yeah.
Set reminders.
Okay.
Even visualize your network through a Kanban-style board.
Oh, wow. I love Kanban boards.
It gives you a clear picture of where each connection stands.
That's so helpful.
It takes the guesswork out of networking.
Makes it way more efficient.
Exactly.
You can see who you've contacted, what you've talked about, and the next steps.
All in one place.
And it's integrated with RoleCatcher's other tools, right?
It is.
So you can go from researching a company to connecting with someone there to tailoring your application.
Seamlessly.
All within the same platform.
That's the beauty of it.
So as we wrap up our electronics engineer deep dive,
Yeah.
what's the key message you want our listeners to take away?
Preparing for an interview, any interview, really,
Yeah.
it's a holistic process, you know?
Right.
It's not just about memorizing answers.
Right.
It's about understanding the industry, researching companies, showcasing your unique skills.
Right.
Building those connections.
It's about approaching your career with intention,
Absolutely.
curiosity, a willingness to learn and grow.
And remember, you're not alone on this journey.
We're all in this together.
Leverage the resources. Find mentors. Embrace those challenges.
The world of electronics is constantly evolving,
It is.
offering endless opportunities.
So go out there, rock those interviews, and build the career you've always dreamed of.
I love it. And a huge thank you to RoleCatcher for providing the resources to help our listeners succeed.
They're a fantastic resource.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible in the world of electronics.